Hello again. We are continuing our discussion of linear equations and slope and all of that good stuff. We're going to talk about direct variation and what that means for linear equations. There's some terms and definitions you need to know. The first one is, first of all, what is direct variation? Direct variation is basically if you take any x and any y from the table of points on that line, then you will always get the same thing. It reminds me of slope. It's not exactly like slope. There's like a slight variation that we need to be aware of. And then the constant of variation is what y over x always represents. Now with lines, change in y over change in x should always represent the same thing. But for direct variation, it's any y divided by any x, not just the change in those y's and x's. So the constant is going to be what you always get when you divide a y by an x in that table. So notice if I write any direct variation as an equation, it's y equals kx. There's no plus something at the end. There's no minus something at the end like you might see with some linear equations. It's just y equals some constant times x. And that constant will be the slope of the line when we graph it. That k value that's being multiplied by x, that's the slope of the line. So here's an example of a graph. So notice how it goes through 0, 0. Okay? Whenever you have a direct variation, that's always going to happen. Okay? It doesn't happen with every line, but it happens with every direct variation. So all I need to do is find some other point on the line, 3 and 60, for example. Any other point would have done. So the slope from 0, 0, which I'm calling old x and old y, to 360, which I'm calling new x and new y, would be 60 minus 0, new y minus old y, over 3 minus 0, new x minus old x. And when I do that, I get 60 over 3, which is 20. Okay, that means that the constant of variation is 20. It's the slope, it's the constant of variation. Same thing when we have a direct variation. So the equation of the line is going to be y equals 20 times x. Okay, so here's how we draw a graph. For example, if I wanted to draw y equals negative 2x, I can always draw 0, 0 because every direct variation has that. And then the slope or the constant of variation is negative 2. So here's how I get some other point on the line. The rise over run, since I have to have something over something and all I have is negative 2, if I have an integer as my slope, I can always put it over 1. So rise over run would be negative 2 over 1. So that means I need to rise 2, which means go down 2. And I need to run positive 1, which means go to the right 1 space, and I get another point. And now I can join those 2 points and keep the line going in both directions, and there's my graph of the equation y equals negative 2x. All right, now you may be given an equation or a question that talks about y varying directly as x. That's another way of saying direct variation. The root words of both of those are right there. So you're given 3 pieces of information and you're asked for a 4th piece of information. So we can always solve these with proportions, which we talked about in the last chapter. As long as you keep your information straight and organized, then you should be able to solve these correctly every time. So for an example, I have y varies directly as x. When x is 10, y is 6. Find x when y is 15. So when I set these up, I either always want my x's on top or I always want my y's on top, but I can't mix and match. I can't have x on top of one fraction and y on top of the other because then you'll get bad answers. So I set up a proportion as y over x equals y over x. And I use the x and y from the first sentence for the first fraction, and I use the x and y for the second sentence for the second fraction. So I have 10 and 6 in the first sentence. So my first fraction is going to be 6 over 10. And then in the second sentence, I have some unknown x and y is 15. So I'm going to write y as 15, but that unknown x, I'm going to keep it as just x. And then how do I solve proportions? I cross multiply, I use cross products. So 6 times x is 6x, and then 10 times 15 is 150. That's my equation that I need to solve. If I divide both sides by 6, I get that x is 25. So that's how you solve one of those types of equations. Okay, here's a real life example of that. I have a circumference of a circle, and it always varies directly as the diameter. Okay, so as the diameter increases, the circumference increases by a constant amount. So I have a circle of diameter 4 that has a circumference of 6.28. And then I have another circle. I don't know what the circumference is, but I know that the diameter is 10. Okay, so I'm going to make two ratios, make a proportion out of them, and I decided to put C on top and D on the bottom. So in the first sentence, I have a diameter of 4 and a circumference of 6.28. So my first fraction is 6.28 over 4. And then in the second sentence, I don't know what the circumference is, but I know that the diameter is 10, so I put x over 10. I could have left it as C for circumference. That would probably have been better, but I'll call it x and then put the diameter on the bottom as 10. So if I cross multiply, I get 6.28 times 10, which is 62.8, and I get x times 4, which is 4x. Divide by 4, and that gives me a circumference of 15.7. So the circumference of the second circle would be 15.7 meters. That is direct variation in a nutshell. If you have any questions, please let me know, and I will see you tomorrow.